I'm Dr. Sumit Majumdar. I'm a pass out of IIT-JEE. I'm from the 2003 batch. Since then, I am with askIITians. So today, we'll be discussing about physical world. So what is physical world all about? Physical world is everything that surrounds us. All the physicality that we see around us is included in the physical world. Whether there is a snail that is moving on the road, how much is the distance that is covering, or there is an ant moving on the road, how much is the distance it is covering, or how much rate it is moving. These are all the small things that we need to understand. So let's try to understand about that in this particular chapter of physical world. So the first part of this is going to be about what all we are going to discuss, and we are going to understand what basically are the physical dimensions, what exactly are the physical units. So in the first part, we'll be discussing about that, and then we'll take it forward from there. So students, we will be starting off with a new chapter, that is physical world. So let's understand what do we have to discuss in this particular chapter. So the first thing that we need to understand is about the learning outcomes. What exactly are we going to learn in this particular chapter? So to put it precisely, I have put it down in the form of some points. So let's try to discuss about with the help of some points. The first point, understand that physical quantities have numerical magnitude and a unit. So numerical magnitude, basically every quantity that you see around yourself has some magnitude to it. For instance, if you are going by a certain distance, you will say that you are going by certain meters. Let's say 2 meters, 3 meters, 4 kilometers, 3 centimeters if something is being measured and something, so on and so forth. Right? In the same way, if you say that any particular quantity has some weight, you generally use the kilogram or grams, right? So you say 3 kilograms, 2 kilograms, 200 grams, and so on and so forth. So everything has a magnitude that is associated with it, right? Apart from that, you associate a unit, like you say kilogram, meter, centimeter, and so on. So that's a unit that is associated, right? Then if you have to say that what are the base quantities, and we also use some prefixes. What basically are the base quantities? Base quantities, as the name itself suggests, these are the basic quantities in terms of which you define rest all the quantities that are defined in physics. Yeah, so that is what is known as a base quantity. Now supposing you have defined a base quantity, but that base quantity is very small in terms of magnitude as compared to any other quantity that you are measuring. Obviously, you cannot keep on writing down 0, 0, 0, 0, and so on and so forth. So therefore, you will say that you have to use some prefixes or suffixes that are utilized so as to help you in concising or compressing the denotion, right? So that is the usage of the base quantity and the prefixes. Then we have to also understand the comparison of the magnitudes. Yeah. Different quantities obviously will have different magnitudes. You can have a 1 gram mass, you can also have a 10,000 kilogram mass, right? So obviously you need to understand what is the difference between a 1 gram mass and a 10,000 kilogram mass. So that's the order of magnitude difference. Even though you'll be measuring it in kilograms or grams or whatever it is, there is still a order of difference. Then we need to understand about the quantities. Every physical quantity we generally define into two basic parts, that is, one is defined as a scalar quantity, other one is defined as a vector quantity. So we need to identify what are scalar, that is, which are the quantities that depend upon the direction, and which are the quantities that don't depend upon the direction. They can be defined without the help of direction. You obviously need some units to define it, but the direction is not necessary to be defined for certain quantity. For example, if you are trying to measure the mass, you are not going to say that if you measure the mass going towards north, is going to be this thing. If you measure the mass going towards south, this is going to be different than something else. So that is what is known as understanding what is a scalar quantity and what is a vector quantity. Then determine the resultant vector by graphical method. Resultant vector, when you define the vector quantities depend upon the direction. They depend as to whether you are going from, let's say, point A to point B, whether it's going from east to west, it's west to east, south to north, or whatever direction that they are, there is a direction that is associated with it. right? So therefore, when you have different quantities that have different directions, if you have to find out the resultant value, in that case you have to sum up those resultant values, right? So that is the understanding of the resultant using a graphical method. We'll try to understand that. Then, like you have to measure different things. Let's say if you have to measure the length. So if you are trying to measure the length, there will be different types of instruments that you are going to use. You can have meter scale. Then you are also going to use some precise instruments which measure up to a certain level of accuracy. Right? Using a meter scale, you can go up to, let's say, centimeter and millimeter. If you want to go further down, let's say 0.1 centimeter, 0.01 centimeter, 0.001 centimeters, then you cannot use the meter scale, right? So there are certain instruments which are utilized to measure those dimensions or measurements. So we are going to understand that the measurement of the length using the instruments. Similarly, how we can identify or measure short intervals. Short intervals, like if you are running in a race, then there are stopwatches that are utilized. Right? You cannot use a watch to understand how much is the time that has moved, because there is going to be a difference in seconds, milliseconds, microseconds and so on. So you cannot use a watch because you cannot identify that. So measurement of short interval of time using the short watches, right? So hopefully you understood till this point. Now let's move on and try to identify about the physical quantities. First thing first, when we are talking about any physical quantity, there are two types of measurements that we generally have. First one is a qualitative measurement, then you have the quantitative measurement, or vice versa, whichever way you like to put it. So quantitative means you quantify the things, you measure and associate a particular value to it. So that is what is known as a quantitative measurement. When we are talking about a qualitative measurement, what is qualitative? Qualitative is something where you do not really identify or make some measured value to it. You just give a qualitative description that it is good, it is bad, or it is not useful, or it's very useful. That doesn't really give a significant value. Yeah, why? Because it may be good for you, it may not be good for somebody else. It's a perception that we look at, correct? So let's try to identify that. There are many observations which are quantitative, there are many observations which are qualitative. If you look at any galaxy, for instance, using a galaxy, until and unless you measure how far it is, the galaxy, from Earth or from solar system, and similarly what is the extent of that galaxy, how fast it is accelerating or decelerating, or how fast it is expanding or contracting, you cannot really say. Just by looking at it, at the most you can say that it's beautiful, that's it. So you cannot really measure the quantity of artistic beauty in it, right? So that is a qualitative measurement. Now if you have to measure it quantitatively, quantitative measurements are done using instruments. So what are the different types of instruments? For instance, if you look into the aeroplane dashboard, you see all sorts of humongous instruments that are there in front of you, right? So they are instruments. Using instruments, you measure the things, okay? Fine. So moving on from there, let's try to identify what is a physical quantity. So physical quantity is one that can be measured and consists of a magnitude and unit. Measured means you cannot measure the artistic beauty. You have to be logical, you have to measure something which can be measured. Yeah. So something which can be measured, for instance, the length of a wire, it can be the weight, if you would like to say, the mass. Similarly, you can measure the time and so on. So everything, you cannot say length is in seconds, you cannot say weight is in meters, you cannot say time is in kilograms, right? That is not really possible. So when you have to measure any particular physical quantity, you need to associate a magnitude, and with that magnitude you also need to associate a unit. For instance, you have 70 kilometers per hour. We know that this represents the speed of a moving object. You are associating a number. Number means you are measuring it. You cannot randomly say that it is 70 kilometers per hour if it is moving some other speed. So you are measuring it, and therefore you are associating a number to it. So this has to be measured, and there are different system of units. So the SI system, which is the most commonly utilized system, is known as the Standard International System of Units, which we use generally to measure our quantities. Similarly, if you have to measure the length, the length is going to be measured using a scale, and further there are different other ways. Further, if you have to classify the physical quantities, we classify them into two basic parts. That is, there are base quantities and you have derived quantities. So as the name itself says about the base quantities. So base quantities are the building blocks, and derived quantities are something from which those base, when you just combine, let's say, bricks, when you have each brick is a base quantity, and if you build up a house, so house is nothing but a derived quantity. So this is the way you derive from the base quantity a derived quantity. So brick, if you would like to say, so this is what is a base quantity, and each brick, when you combine them together, that gives you what is known as a derived. Derived means which does not have any existence of its own if the base quantity does not exist. If there is no brick, you cannot build the house. Let's not be more controversial on that, whether you can build a house or not without from brick. But let's say that we have a brick house, and therefore we need the bricks, right? So bricks are the most important thing, that is the base quantity. So students, we learned about what are the different types of units. Broadly speaking, we learned that we have two basic types of unit. One is the base unit and another one is a derived unit. So base unit, as we understood, is the basic form of unit based on which all the SI systems is defined. And then we have the derived system of units, which is based on the SI system, or which is based on the base system. And like the brick and the mortar case that we considered. Brick being the basic thing, and the house is the derived unit, which is based on the brick. So this is what we learned here. Now we need to go further and try to identify the different forms of SI units. So stay tuned for that.